Hello friends, welcome back to our channel. Today in part 9.2 of our Mastering Multithreading series, we will explore the world of locking mechanism in C# for effective thread synchronization. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. Thread synchronization locking mechanism in C#. Locking mechanism in C# are synchronization techniques used to ensure that only one thread can access a particular section of code or a shared resource at a time. Locking is essential to prevent race condition and data corruption when multiple threads concurrently access modified shared resource. So there are two categories of locking mechanism: exclusive locking and non-exclusive. Exclusive locking in C# means that only one thread can use a particular resource or section of a code at a time. For example, lock, Mutex and spin locks are the option by which we can implement exclusive locking. Coming to the non-exclusive locking, it means that multiple threads can use a particular resource or section of code simultaneously. For example, Semaphore, SemaphoreSlim, ReaderWriterSlimLock are the option by which we can implement non-exclusive locking. Exclusive locking mechanism in C#. Here we are going to look at some of the common exclusive locking mechanisms in C#. Number 1, lock statement. The lock statement built on the monitor class provides a straightforward way to achieve exclusive locking in C#. It ensures that a block of code is executed by only one thread at a time. Okay, let's understand with the help of analogy over here. Let's think of a lock in C# like a bathroom door lock. When you go into a public bathroom, often see a lock on the door. So this lock prevents more than one person from entering the bathroom at the same time. In C#, a lock is similar concept. It's a way to make sure that only one part of a computer program can access a particular piece of data or code at a time. This can be important when multiple parts of the programs are running simultaneously, like multiple people trying to use the bathroom. Right? So when we use lock in C#, we are essentially saying, hey, only one part of the program can use this data or code right now, and the others have to wait their turn. This helps prevent conflicts and ensure that everything works as intended. If you see the example shown over here, how we are going to implement in C#. So here, first we need to create an object. That's what I have written. Object, lock object is equal to new object. So here basically I am creating an object. I have given the name as a lock object. And we are using this lock statement over here. In lock statement, we are passing this object, lock object. In this lock statement block, we are going to execute some code exclusively by one thread at a time. That's what this lock statement is going to help. Now, if you see the right hand side, I have used this Monitor.Enter and Monitor.Exit. Right? Basically, lock is shortcut syntax of this Monitor.Enter and Monitor.Exit class. Okay, so if you see here, what is the difference? I have created an instance of this object, right? Object lock object is equal to new object, and here instead of lock statement, what I have done, I have used this enter method of this monitor class. So monitor.enter, and here I am passing lock object, right? And then what I'm doing, I'm just using try and finally block over. Catch block is optional, you can write it, but this try and finally we need to write it. In this try block, we need to write the code that should be executed exclusively by one thread at a time. And finally, when everything is done, then it comes to the finally block. Here we need to write Monitor.Exit lock object. So basically, here we are capturing the lock and here we are releasing the lock. That's what we need to use this Monitor.Enter lock object and here Monitor.Exit lock object. So this is the statement right side. It is just equivalent to the lock statement. Only the difference is here we are writing Monitor.Enter, Monitor.Exit. Here lock statement is going to internally implement the same thing. Okay, now let's see the second exclusive locking mechanism, which is nothing but the mutex. Mutex, it is similar to the lock keyword except that it can work across multiple processes. Okay, let's understand this also with the analogy. So a mutex in C# is like a special key to a room that only one person can have at a time. Let's imagine a room with valuable things inside. There is only one key to that. If someone wants to access the room, they must first get the key. While one person has the key and is inside the room, no one else can get in. They have to wait their turn. Right? In computer program, a mutex works similar fashion. It ensures that only one part of the program can access a specific resource or area of a code at a time. If one part of the program has mutex, nothing but the key, it can access the resource and other parts of the program must wait until it's done. So this is useful in situation where different parts of a program need to share data or resources, but you want to make sure that They don't interfere with each other and causes problem. The mutex acts like the key to control access and makes your things happen in orderly, one at a time manner. Here is how you can use the mutex. So here what we need to do, we need to just create an instance of the mutex. That's what I have written, mutex is equal to new mutex, false, and my mutex. Here we just need to pass the key of for this particular mutex. So here I have given the key is a my mutex over. Now what we are doing, I'm just writing the if block. In if block, we are just checking mutex.wait1, and then in this try block we need to write the code that should be executed by only one thread at a time. And this try block we are going to put the code that will be executed exclusively. Then in the finally block I am just releasing the mutex. What I have written, mutex.release. That's how we are going to implement mutex in C# program. Now let's see the another exclusive locking mechanism, which is nothing but the spin lock. The spin lock is a lightweight locking mechanism that uses busy waiting acquire locks. It is suitable for low contention scenarios and should be used with caution, as it can lead to the high CPU usage in high contention situation. That's what it is suggested. It should be suitable for the low contention situation. Okay, let's understand this one also with analogy. A spin lock in C# is like a group of people standing in line for a popular ice cream truck. But there is a rule. If one person is already at the ice cream truck, the others don't just wait in line, they keep asking, is it my turn yet? Can I have the ice cream now? They keep asking over and over without waiting patiently. So we can say that in computer program, a spin lock is a way to control access to a particular piece of code or data. When one part of the program is using that code or data, other part don't just wait patiently, they keep checking repeatedly to see if they can access it. This constant checking is called the spinning. So spin locks are very fast because they avoid the overhead of putting one part of the program to sleep while waiting for access. However, they can be inefficient if many parts of the program are constantly checking and spinning, because it can waste a lot of processing. So a spin lock is like a group of people who don't want in line but keep asking if it's their turn, which can be if done accessibly in a computer program. So here is how we are going to use in a C# program. For that, what we need to do, we need to create an object of this spin lock. That's what I have written, a spin lock. A spin lock is equal to new spin lock. Here we need to create a boolean variable. That's what I have created, bool lock taken is equal to false. Initially we are setting lock taken value as a false. Then in this try block, what we are trying to do, we are going to use this enter method of this spin lock object, right? The spin lock dot enter, and here what I'm going to do, I'm just writing ref lock taken. After that, we need to write the code that should be executed by only one thread at a time. Basically, this is the section we are going to put the code that should be executed exclusively, right? And in the finally block, I'm just going to check, okay, if lock taken is true, then what we need to do, we just need to exit from the spin lock dot exit method we are going to call, so that whatever the lock we have already placed, it is just going to release that lock. For this spin lock dot exit method is going to do. So that's how we are going to implement a spin lock. Okay, let's switch to the Visual Studio and see all these things in action. Okay, so here we are in Visual Studio. Here what I'm going to do, I'm going to show you a problem that can occur without using the lock statement. Then I will implement the lock statement to resolve the issue. Okay, so in this program, let's consider a scenario where multiple threads are trying to increment a shared variable value without any synchronization. This can lead to incorrect results and data correction. So you demo what I have done, I have created one console application named locking mechanisms in C#. It has program.cs file. In program.cs file, there is a class named program that has main method, which is an entry point of this application. As a first statement, I'm just printing this statement into console. Then there is a variable named int value of int data type. I have assigned value to 0 to it. This is the shared variable over here. Then there is an increment method that has for loop. This for loop is going to execute 1 million times. In every time, it's just going to increment int value by 1. Then final int value, I am just printing into the console. And this increment method, I am calling from two different tasks. That's what I have written, task.run increment task.run, so that it will call this increment method. Okay, so that's the program. Let me execute this program and see this output to you. Let me build this. Okay, so build got succeeded. Let me go and execute this program in the terminal. Just need to use this locking mechanism in C#.exe. Let me go and take this int. Okay, if you see, this output got appear into this console. Task 1 printed this final int value is 132.135.2409, and the second one is also same. Let me execute the second time. The value got printed 105350 105350, right? It's also not correct. Let me go and execute the third time. And now the value got printed 106173, right? Let me go and execute more time. Okay, the value got printed 1366900 1366900. You have seen, for every run we are getting the final int value. Every time we are getting the different value. Okay, let me modify this program and use this lock statement. Okay, so I have modified this program. Here what I have done, I have created one new object, right? Private static read only object int value lock is equal to new. Then what I'm doing, I have used this lock statement over. Inside this lock statement, I am accessing this int value shared variable and incrementing by 1. That's the changes I have made in this program as a part of lock statement. Okay, so let me execute this program and show this output. Let me go and build this solution. Okay, so build succeeded. So let me execute this locking mechanism in C#.exe. Go and let me enter this. Okay, if you see this final int value 1925380 by task 1 and the second final int value is 2 million got print, right? So let me execute the another time. Another time also the final int value is 2 million got print, right? Okay, so let me execute the third time. Again it is coming as a 2 million record as a final int value. It's a consistent, right? So now the final int value for the task 1, it is coming differently, right? And whatever the value that we are going to get it, but it is just making sure that the second time when this increment method is going to get called, the final int value should be 2 million only. Because the first it is just going to execute 1 million time, final int value is just going to print the 2 million. So that's the lock statement benefit. It is just going to get executed in a synchronized way. Now I have modified this program. Instead of lock state, I have written this program with the help of Monitor.Enter and Monitor.Exit as a part of exclusive locking, right? So here the same program we have created this, lock over here that I have given the name as int value lock. And then here instead of lock, I have used Monitor.Enter int value lock. Then I have used try block over here, and then I'm just incrementing int value by 1 over here. And in the finally I'm just executing from this monitor. So that is the only change I have done in this program, but output will remain the same as we were getting for the lock state, right? Let me go and execute this. First of all, let me build this. Let me go and execute this program. You see this final int value got printed 2 million, right? Let me execute one more time. Again we got the value is 2 million. Value is intended value that we are getting, even though we are using Monitor.Enter and Monitor.Exit instead of lock statement. Lock statement and Monitor.Enter and Monitor.Exit both are going to give the output as the same, because the lock statement is a shortcut of this Monitor.Enter and Monitor.Exit. It is going to get implemented internally Monitor.Enter and Monitor.Exit. So here we are going to see the demo of Mutex. First again we will be seeing the problem, and then we will be implementing the Mutex and resolve this problem. Okay. So in order to show the demo, what I have done, I have created one console application named locking mechanism in C# and it has program. In program.cs file, there is a class named shared resource. It has one access room method that is going to get this int person number as an input parameter. Then this statement, I am just printing the whole right line person number is entering into the room. Then I'm just making this thread to sleep for 1 second, because I just want to make sure that that person spends some time into the room. Basically I'm simulating that behavior over here. Okay, then finally I'm just printing this statement, person number has left the room. So that's what this access room method is doing in this shared resource class. Now there is another class named program that has main method, which is an entry point of this application. Here I'm just printing this statement, problem without mutex exclusive locking, that is going to cause as uncontrolled access. So here I'm just printing this statement, problem without mutex uncontrolled access, right? So here what I have done, I have created one instance of this shared resource. I have written shared resource shared room is equal to new shared resource, and then there is a for loop that is going to get executed 5 times. Here I'm just assigning int person number is equal to I, and then I'm just creating a thread with the help of this statement. Thread is equal to new thread, and here I'm just calling this shared room dot access room method. Here I'm just passing the person number, and then I'm just starting this thread. Finally, I'm just writing this statement console.read line, right? Let me execute this program and show this output to you. So here I'm just going to run this program, right? So for that, I'm just going to click enter button. You see, this output got appeared. Problem without mutex exclusive blocking uncontrolled access. You see, person 5 is entering into the person 3, person 1, person 2, person 4. Then person 4 has left the room, person 2 has left the room, person 1 has left the room, person 5 has left the room, person 3 has left. If you see, there is no control access, right? For that particular room. Anybody can go, anybody can come out from that. That's what it's happening over here. Person 5, 3, 1, 2, 4 got entered into the room. Then person 4, 3, 4, 2, 1, 5, 3 got executed from this. So that's the problem we are going to face without the use mutex. Okay, so let me modify this program where I will be using mutex exclusive locking operation to get the control access to the room. So here I have modified this program in order to use mutex concept over. So in class shared resource, what I have done, I have created an instance of this mutex class. That's what I have written: private mutex. Mutex is equal to new mutex, and it is going to help us to control access. Okay. Now in this access room, what I have done, I have used this wait one method of the mutex also. Mutex.wait one, basically it is just going to acquire the key to the room, right? That's what this statement is going to perform. And then once this key is acquired, we are going to enter into the room. That's what console.writeLine person number is entering the room. Thread.sleep 1000, because I'm just simulating that person is going to spend some time in the room, right? So thread.sleep 1000. Then this statement I have written because this person number has left the room, and then I'm just releasing this mutex key. That's what I have written: mutex.release mutex over, so that this mutex becomes available for the next portion. So that's the changes I have done in this program, and every other things remains same. Okay, so let me execute this program and show this output. Let me build this solution. Okay, so build got succeeded. Let me execute this program, and you see the output has started coming into this control, right? Problem resolution with mutex exclusive locking controlled access got printed, and then person 5 is entering the room and person 5 has left the room. Person 2 is entering the room, person 2 has left the room. Person 1 is entering the room, person 1 has left the room. Person 3 is entering the room, person 3 has left the room. Person 4 is entering the room, and the person 4 has left the room. You see, one person is going to enter in a room at a time. So there is a controlled access. Person 5 has key entering into the room. When it is come out, then it is just handed over key person number 2. Person number 2 is entering into the room, and when he came out, he is just handing over the key to person 1. So in this fashion, this mutex is able to control access to a particular. It just resolve the issue what it was happening earlier. So here now we are going to see the problem without a spin lock causing uncontrolled. And then I will be implementing a spin lock concept to provide the control access. So for that, what I have done, I have created one console application talking my C# that has program.cs. This program, there is a class named ice cream truck, has one method get ice cream. It's going to accept person number as a in data type. Okay, what this get ice cream method is doing, it is just printing this statement console write line person number is asking for ice cream, and then I'm simulating some work so that it is spending some time to serving the ice cream. That's what I have written: thread.sleep. Then I'm printing this statement console.write line person number has ice cream. So that's what this get ice cream method is doing. Now there is another class named program that has main method, which is an entry point of this application. Here I am just printing this statement: problem without a spin lock, exclusive locking, uncontrolled. Then I'm creating an instance of this ice cream truck class over here. Then here what I'm doing, I'm just creating an instance of this ice cream truck class. That's what I have written: ice cream truck is equal to new ice cream truck. Then there is a for loop that is going to get executed 5 times. In this for loop, I'm just assigning this person number to I. Then I'm creating one thread. I'm calling this get ice cream method with the help of ice cream truck object. Here I am passing this person number to it. Then I'm starting the thread. That's what this for statement is doing inside, right? Then I'm just writing console.read. That's what this program is doing. Let me execute this program and show this output. First of all, let me build this solution. Okay, so solution got built. Now let me go and execute this program. Okay, now if you see, problem without spin lock exclusive locking uncontrolled access got printed, and then person 2 is asking for a ice cream, person 4 is asking for ice cream, person 3, person 5, person 1. Person 1 has ice cream, person 3 has ice cream, person 5 has ice cream, person 4 has ice cream, person 2 has ice cream. You see, person 2 is asking for ice cream first time and it got at the last. So it is not a consistent behavior, right? So this is the problem we are going to resolve while implementing this spin lock concept. Let me modify this program. Okay, in order to save the time, I have already modified this program. Here I'm using the spin lock concept. Okay, so here what I have done, I have created one object of this spin lock class. That's what I have written, private spin lock is equal, and it will help us to make sure that we are providing the control access to the ice cream truck. Okay, so here in this class there is a method get ice cream that is going to accept person. First of all, I have initialized this lock taken of the boolean data type to false. Then in try block, what I'm doing, I'm just using this enter method of the spin lock class. So this enter method is making sure that we are going to enter the ice cream truck line and taking the control. That's what a spin lock dot enter ref lock taken I have mentioned. Then I am just printing this statement, person number is asking for ice cream. Then I'm just simulating time spent serving for the ice cream. Thread.sleep 1000, and then I'm printing this state. Person number has ice cream. So this is the way how we are going to implement a spin.lock enter. And in finally block, if lock is taken, then I'm just going to exit this spin lock so that some other person is going to ask and their ask is going to get served, right? So I'm releasing this spin lock over here. Okay, so that's what the changes I have made, and other things remain same. So let me go and execute this program. Before that, let me build this solution. Okay, so I built this solution and let me go and execute this program again. Okay, so let me go and see. Now this output has started coming over here. This statement got printed, problem resolution with a spin lock, exclusive locking, controlled access. Person 1 is asking for ice cream, person 1 has ice cream. Person 4 is asking for ice cream, person 4 has ice cream. Person 2 is asking for ice cream, person 2 has ice cream. Similarly, person 5 asking for ice cream, person 5 has ice cream. Person 3 is asking for ice cream, and then person 3 has ice cream. So whoever is asking the ice cream, that person is going to receive this ice cream by the person who is going to serve this ice cream to the requested part, right? So it's a controlled manner. That's how a spin lock is going to help us in this type of non-exclusive locking mechanisms in C#. Here we are going to look at some of the common non-exclusive locking mechanisms in C#. Number 1, semaphore. Semaphore is used to limit the number of threads that can have access to a shared resource concurrently. It's used to control the number of consumers for a specific shared resource. Okay, let's understand with the help of analogy. Let's imagine a busy road junction with many roads coming together, and it's controlled by a specific traffic signal. This traffic signal is like a semaphore. It can change colors to control the flow of traffic. When the traffic signal is green, it means that cars from one direction are allowed to move, while cars from other direction have to stop and wait. The signal can change to red to stop cars from one direction and let cars from another direction. In the world of computer programs, a semaphore works similarly. It's a tool that helps control the access of multiple parts of a program to a shared resource, just like the traffic signal controls which cars can pass through the junction, right? If a semaphore is like a green light, it allows a certain number of program parts to access the resource at the same time, and the rest have to wait. When it's like a red light, no one can access the resource until the semaphore changes to the green again. So this helps ensure the different parts of the program don't interfere with each other and that everything runs smoothly. Just like a traffic signal keeps traffic orderly and safe at a busy junction, right? So how we are going to use it semaphore in C#? For that, we can see the examples over here. So here basically I am creating an instance of this semaphore. That's what I have written. Semaphore obj semaphore is equal to new semaphore 2 comma. So first parameter is the initial count and the second one is the maximum count. Okay, so basically we are saying that we are going to allow two concurrent threads with the help of semaphore. That's what I have created an instance of the semaphore in this fashion. Then what we need to do, we just need to call this wait1 method with the help of this obj semaphore, right? And then try and finally block we need to write. Try block, we need to write the code that should be executed by only one of the two allowed threads, right? And then finally we are going to release the semaphore object. So that's how we are going to implement semaphore in C#. Now let's see the another non-exclusive locking mechanism, which is SemaphoreSlim. It is a fast, lightweight alternative to the semaphore class to implement non-exclusive lock. Okay, so let's imagine same BG load junction controlled by a specific traffic signal like the one at the traffic junction, right? So this traffic signal is like a SemaphoreSlim. It can change colors to control the flow of traffic just like a regular semaphore. However, a SemaphoreSlim is like a more modern, energy efficient version of the traffic signal. It can still change colors to control the flow of traffic, but it does so with less energy and is quicker to respond. So in the world of computer programs, a SemaphoreSlim is a tool that helps control the access of multiple parts of a program to a shared resource, just like the traffic signal at the junction. It's more efficient and responsive compared to the regular semaphore, making it a good choice when you want to manage access to resources with less overhead. So here how to use SemaphoreSlim in C#. First, what we need to do, we need to create an object of SemaphoreSlim. So that's what I have written. SemaphoreSlim, semaphore is equal to new SemaphoreSlim, initial count and the max count. Basically, we need to mention what is the initial count, what is the max count, that we need to pass in the constructor of this SemaphoreSlim. Right? So once we create this object, we can acquire a slot. How we are going to use the acquire a slot? With the help of wait method. So we need to write semaphore.wait. Once we acquired a slot, what we need to do? We need to perform some work inside the protected section. Then when our work is done, we can release the acquired slot. How we are going to release the acquired slot? So basically we are going to use the release method. So we need to write semaphore.release. That's how we are going to leave the semaphore from this point. So that's how we are going to use the SemaphoreSlim in C# program. Now let's see another non-exclusive locking mechanism, which is nothing but the ReaderWriterSlimLock. It allows multiple threads to read a resource simultaneously but prevents concurrent write access. Let's understand with the help of analogy over here also. So ReaderWriterSlim can be compared to a library where people want to read books and some want to write new ones. So in this library, there is a librarian who ensures everyone gets a fair chance. Here is how it is going to work. So there are three concepts into it. First, readers, people who want to read. So many readers can come in and read books at the same time. The librarian lets them in without any problem. Number two, writers, people who want to write new books. When a writer wants to come in, the librarian says, wait, I need to make sure that no one is reading right now. Once all the readers are done, the writer can come in and start writing. And number three, exclusive writing. While a writer is inside, no readers can come into the read. So this gives the writer a peaceful environment to work without disturbance. So the key idea is that many people can read simultaneously, but only one person can write at any given time. This way, the library operates efficiently with minimal waiting and ensures that writing new books doesn't interfere with reading existing ones. So here is how to use the ReaderWriterSlim. So here, first of all, what we need to do, we need to create an instance of this ReaderWriterSlim. That's what I have written. ReaderWriterSlim rwlock is equal to new ReaderWriterSlim. Once we create an instance of this ReaderWriterSlim, what we need to do, we need to acquire a read lock. How we are going to acquire a read lock? We are going to use this enter read lock method. That's what I have written, rwlock.enter read lock. So this statement is basically helping us to acquire a read lock. Then what we need to do? We need to perform some read operation inside the protect. To release the read lock, we need to use this exit read lock method. So that's what I have written, rwlock.exit read lock. When we want to acquire a write lock, we need to use enter write lock. So that's what I have written, rwlock.enter write lock. Then we need to perform write operation inside the protected. And once our writing is complete, we can release the write lock using the exit write lock. But we need to write rwlock.exit write lock. So now you have basic idea. What is Semaphore? What is SemaphoreSlim? What is ReaderWriterSlimLock, right? Okay, so let's now switch to the Visual Studio and see all these things in action. Okay, so here we are on Visual Studio. Here what I'm going to do, I'm going to show you a problem that can occur without using the semaphore concept, and then implement the semaphore concept to resolve the issue. Okay, let's consider the scenario where multiple cars presenting threads are approaching a busy junction and there is no traffic control, which can lead to traffic chaos. And this is the problem, and then we will be implementing semaphore to control the traffic and resolve the issue. For that, what I have done, I have created one console application named locking mechanism in C#. It has program.cs. In program.cs file, there is a class named traffic system that has interjection method to it. And this interjection method is accepting car number of in data type. It is just printing this statement. Console.writeLine car number is entering into the junction. Then thread.sleep 1000. Why I have written this statement? Because I'm trying to simulate the time it takes to pass through the junction for a particular car, right? Then I'm just printing this statement. Console.writeLine car number has left the junction. That's what this interjection method is doing of this traffic system. Okay, now there is another class named program that has main method, which is an entry point of this application. Here I am just printing this statement, demo of problem without semaphore, non-exclusive blocking traffic queue. Then what I'm doing, I'm just creating an instance of this traffic system class. That's what I have written, traffic system is equal to new traffic system, and then there is a for loop that is going to get executed 5 times. Then this for loop, what I'm doing, I'm writing int car number is equal to I. So basically I'm assigning I value to the car number. Then I'm creating an instance of the thread and calling this interjection method of traffic system, right? And I'm just passing this car number to it. Then finally I'm starting this thread. That's what this program is doing. Let me execute this program and show this output. Then let me go and execute this program. If you see, this output has started coming, right? Demo a problem without semaphore, non-exclusive blocking traffic queues. Car 3 is entering the junction, car 2, car 5, car 1, car 4. Car 2 has left, car 5 has left, car 4 has left, car 3 has left, car 1 has left the junction. There is no control in passing this junction, right? Car 3, car 2, everyone is entering. And if you see here, car 3 entered first, but it is coming out from that particular junction at the second last position, right? There is a no control fashion. That's what this traffic chaos is going to happen. So how to resolve this issue? So solution is semaphore. What I'm going to do, I'm just going to modify this solution and implement this semaphore concept into see how it behaves. In order to save the time, I have modified this program and implemented semaphore concept to it. Now let me show you what changes I have done. First of all, I have added this statement. This statement is for creating an instance of the semaphore. That's what I have written, private static semaphore is equal to new semaphore 2, 2. Basically, this statement is making sure that we are going to allow 2 cars in a junction at a time. The first parameter basically talks about this initial count. Second parameter, it talks about the maximum count. That's what 2 is the maximum count. So it is just going to allow 2 cars in a junction at a time. Okay. Now in this interjection method, what changes I have done? I have added this statement semaphore.wait1. So that basically makes sure that it waits for the green light. Okay. And then what I am doing, I'm just writing this statement. Console.writeLine car number is entering junction, thread.sleep 1000. Because I'm just simulating the time it takes to pass through the junction. Then I'm writing this statement. Console.writeLine car number has left the junction. Then finally I'm just using this release method of the semaphore. That's what I have written, semaphore.release method, right? So basically what it is going to do, it is just going to make sure that it provides the signal that the car has left the junction. Then Semaphore turns green for the next class. This is the same program class where I have not made any changes. Okay, let me go and build the solution. Okay, so build succeeded. Let me go and execute. Then I'm just going to execute. You see, car 4 is entering into the action, car 1 is entering, car 1 is entering junction. So two cars got entered. Then just exiting it, car 4 has left the junction, car 1 has left the, then again two are going to get access for entering junction. Car 2 is entering the junction, car 3 is entering the junction, right? Car 3 has left the junction, car 2 has left the junction, car 5 is in the junction, car 5 has left the junction, right? That's how it is going to get entered in a controlled fashion. That's how the semaphore is going to help us in this situation. Now, here we are going to see the demo of the problem without SemaphoreSlim implementation that basically causes traffic chaos. So, what I have done, I have created one console application named locking mechanism in C# that has program.cs. In this program.cs file, there is a class named traffic system that has one method interjection. What this interjection method doing is, it is just printing this statement into console window. Vehicle number is entering junction. Then I'm just making this task to delay 1 second. That's what I have written, await task.delay 1000. Here, why I have written, because I just wanted to simulate the time it takes to pass through the junction. Then I'm just printing this statement. Vehicle number has left the junction. That's what this interjection method is doing. Then there is another class named program that has main method. Entry point of this application. Here I have just printed this statement. Demo a problem without semaphore, slim, non-exclusive locking, traffic chaos. Because I'm just giving the demo that is going to create a traffic chaos. Right? For that, I'm just creating one instance of this traffic system. Traffic system, obj traffic system equal to new traffic system. Then I'm creating an instance of this task array, right? So where task is equal to new task 5. Then there is a for loop that is going to get executed 5 times. Here in this for loop, what I'm doing, and I'm assigning the I plus 1 to the vehicle number. Then task I is equal to obj traffic system dot interjection and vehicle number. Basically, I'm just calling this interjection method of traffic system class and passing this vehicle number to it. Finally, I'm just writing this statement task dot when all task. Wait until all the task gets complete, right? So that's what this program is doing. Okay, so let me execute this program. Okay, so output has started coming, right? If you see, demo a problem without semaphore slim non-exclusive locking traffic got print is coming out 4, 5, 3, not in a proper way. It's not in a orderly format, right? So that's what traffic errors could happen. So how we are going to resolve this issue? We are going to use the SemaphoreSlim except in order to resolve this. Okay, so I have modified this program in order to save the time. Here what I have done, a part of change in traffic system class, I have created an instance of the SemaphoreSlim class. That's what I have written, private SemaphoreSlim semaphore is equal to SemaphoreSlim 2 comma 2, right? Basically, I'm just making sure that only two vehicle is allowed the intersection at, right? So there is a interjection method in this class traffic system, right? So here in this, what I have done, I have used this wait async, await obj semaphore dot wait async. It will enter when the green light is on, right? So await obj semaphore dot wait async. This statement I am printing vehicle number is entering junction. Await task dot delay 1000, simulate the type in. Okay, so I built the solution. Let me go and execute it. Okay, so now if you see demo of problem resolution for slim non-exclusive locking traffic. Vehicle 1 is entering, vehicle 2 has left, vehicle 1 has left, vehicle 4 has is entering the junction, vehicle 3 is entering, who has left, vehicle 3 has left, vehicle junction 5 has left. So smooth traffic flow. Okay, so now we are going to see the demo of a problem without reader writer lock slim. So what problem we face when we are not using reader writer lock slim? Okay. In order to show the program, what I have done, I have created one console application named locking mechanism C# that has program.cs file. Program.cs file, there is a class named library that has two methods, readBook method and writeBook method. In readBook method, what it is doing, it's just printing this statement, reader name is reading a book. Then I'm just making this thread to sleep 1 second. Basically, I'm simulating that person is this much time is reading for that much. Okay. Now, after this thread.sleep method, what I am doing, What I'm doing this statement, reader name has finished reading. That's what this read book method is doing. Then there is a write book method. What I'm doing, I'm just printing this method in this statement. Writer name is writing a new book. Then I'm making this thread to sleep for 1 second, and then I'm just printing this statement. The writer name has finished writing. Now there is another class name program that has main method, which is the entry point of this application. So here I'm just printing this statement, demo a problem without reader writer lock stream non-exclusive. Here what I have done, I have created an instance of this library. This is nothing but the library class. So here I'm just creating an instance of this library. There is a for loop going to get executed 3 times. Here what I'm doing, just putting reader number is equal to I, the value I that is going to get received as part of for loop execution. That value is going to assign to the reader number variable. Then just executing one task. Under the task, what I'm doing, I'm just calling this read book method. I'm just passing this reader number. So that's what this method is going to do. Now there is another for loop that is going to execute 2 times. Here what I'm going to do, I'm using this writer number variable where I'm just assigning the value I to it, and then I'm just executing this task. That task I'm executing this write book method. Library.writeBook method, and this writer number I'm just passing to it. Then console.writeLine library mayhem. Okay, so that's what this program is doing. Let me go and build this program. Okay, so build one succeeded, execute this. If you see one person is reading a book and same book is being written by the particular writer, right? So it is just creating an issue, right? In order to resolve this issue, what we are going to do, I'm just going to implement reader writer lock slim non-exclusive. Okay, let me go and modify this program. Okay, so I have modified this program. What modification I have done in this program? In class library method, I have created one instance of this reader writer lock slim class. That's what I have written, private reader writer lock slim. Lock slim is equal to new reader writer lock slim, and in the read book method, I'm just using this method of lock slim class, enter read lock. Then this statement is going to get executed. Then once this portion got executed, then I'm just exiting the read lock. So that's what I have written, lock slim dot exit read. Similarly, for writing book also, I'm just putting lock slim enter write book, lock slim exit write book. In between, I'm just putting the statement that I'm planning to print. Basically, I'm simulating that some work is being written by the particular writer, right? That's what this changes I have done in this program, and everything remains same. So let me go and execute this program. For that I need to build that. Go and build succeeded. Now I'm just going to execute this program, right? For that, see here, reader 0 is reading a book, reader 2 is reading, reader 1 is reading a book, reader 0 has finished reading. So if you see, reader 0 is reading a book, and here reader 0 has finished reading, reader 2 has finished reading, right? Then writer 1 has finished reading, writer 1 is writing a new book, and writer 1 has finished writing, writer 0 is writing a new book, writer 0 has finished writing. So it is the situation that reader writer lock slim is managing, that whenever writing is happening, nobody is going to read. So that's how we are going to use this read writer lock slim in such type of situation. Okay, so that brings me to end of my session. To sum up, in this video we learned about locking mechanism in C#. We explored the concept of exclusive or non-exclusive locking with examples. So now we can say that locking mechanisms in C# are vital for managing thread synchronization, preventing race condition. Whether we need exclusive or non-exclusive locking, C# provides a variety of tools, techniques to help us ensure safe and control access to the shared resources. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.